right? So I trust you all read the storyline already. It's about these aliens that visit Earth, and they just happen to look like animals from Earth, but they're highly intelligent. Let's hear what they have to say. Right? So that's the rat-looking, well, mouse-looking alien thanking us for sharing his planet, for sharing our planet, right? So they promise to bring peace and harmony to Earth. And the squirrel says, vacation island, so we repay your come vacation on our island to repay your kindness. And of course, the panda-looking alien, right, is just encouraging you all. But not all is what it seems on this island. So we're going to discover the secrets, the true secrets of Fufu Island as we go along today. All right, so today, right, let's see what's going on here. So apparently underneath the island, they enslave all the humans that visit the island. All right, so you can just quickly read the storyline here. We're still waiting on a couple of people anyway, right? All right. Hey, what's going on? I wonder if I load it. Just someone, guys. I wonder if I load. All right. So this is today's topic, right? And today we're doing the testing for cat ions. How much of you all completed this in school already? Cat ions, if you can't remember, are atoms that have a positive charge. So that means they lack what? Electrons. Okay? So some of y'all might just need a little refresher on what a cat ion is. And of course, I have to show you how to test them. And of course, these are the things we're assuming today, but I mentioned this last week. But let's do a quick revision exercise without looking back in your books. I promise me, no looking back in your books. This here is a small little exam, very, very, very small quiz on to guess the gases. So I want you all to read everything through. Behind each colorful rectangle is a gas. See if you could figure them out all without looking back. Right, so for the red one, I suspect it was ammonia, and a lot of people did get that correct. The orange one, it's a colorless and odorless gas. And of course, we know this is to me, this is the easiest one. When you bubble it through lime water, which is a solution of calcium carbonate, you get what? A kind of white or cloudly white precipitate. PPT stands for precipitate. So the orange one is definitely carbon dioxide. A pale green, there's only one pale green gas on the syllabus, right? Only one. And that has to be chlorine, right? So you know that one is from a mile away. The green one, which one gives you the squeaky pop? Hydrogen or oxygen? The green one, right? The squeaky pop is hydrogen. Don't mix it up with oxygen. Oxygen is the one that relights the glowing splint, or just relights a splint. The last one. What is the last one? We spent a lot of time on that one. The one, it's the only one where we mention potassium, manganate, and whatnot. Which one is that? Right, Gaida, correct. Anybody else want to take Anjali, not totally correct. You just said now you had to name the entire gas, right? Right. And a lot of people are saying it's sulfur dioxide. Great. Right. Now, of course, these things are worth a ton of marks in the exam. And of course, when you go to do your labs as well, right? You get SBAs, you need to know these things by heart. So let's move on here. Right. So you all saw this cutscene here already. I'm gonna make you go through it again, right? So they take Jimmy up to the surface to teach him a lesson for trying to organize a rebellion or something like that. Poor humans got tricked into working on Fufu Island. by the evil aliens. All right, so this one here now, just a quick revision as we're going to need it here. Acids, bases, and salts. It's something that we did last term. We all know the general reaction. You take an acid, you add it to a base, and of course, the general result is a salt and water. A salt, a salt is supposed to be what theoretically, what pH value is a salt supposed to have? Theoretically, it's not exactly that, but theoretically, how much is the pH of a salt supposed to be? Right, it's supposed to be neutral. So the pH of a salt is supposed to be roughly around 7, because acids have a pH of less than 7, and bases have a pH of more than 7. All right. So when you mix an acid and a base, fine, we get a reaction. Normally, if you take 2 acids instead and you try to mix it together, you're really not supposed to get a reaction. Generally, let us keep it simple, right? Generally, we don't get a reaction. And of course, if you do the same thing with a base and another base, you really don't get a reaction either, okay? However, right, I'm hoping you all could see this here. It's kind of hard. I don't know what's going on. Let me see if I could change the font. However, there is this thing called amphoteric compounds, which we mentioned last term. Amphoteric compounds, in case you didn't remember, are compounds that it has 2 faces. An amphoteric compound could be an acid, or it can also act as a base. Amphoteric compounds can react with bases and acids. Last term I called them double agents. So amphoteric compounds don't care whether it's an acid or a base. They will still react. Do you all remember the acronym last term to remember the amphoteric compounds? Remember, the amphoteric compounds are basically anything with aluminum in it. Lead, Pb is lead, and Zn is zinc, right? So a lot of people remembered it from last term. The acronym or the sentence was a pink zebra. That's the easiest way. The A stands for what? Aluminum. Lead is Pb, so the P in pink is for lead, and Z is for what? Zinc. So that's the acronym. So basically anything with aluminum, lead, or zinc, they do not cater. You give them a base, they are reacting. You give them an acid, they are reacting. Right? Still take down this, guys. I know some of you all have it from last term, but no harm in taking it down again. Take down everything here. It's going to be a slow build-up on how to test for something called cations. We're no longer testing for gases today. Right? So let me know when you finish. I'm taking my time with this one. Right. So what are ions? Right now, I'm more concerned about cations today. Let's start off with this. Right now, ions are usually anything that has a positive charge or a negative charge. Anything with a positive charge is a cation. Of course, anything with a minus sign is an anion. Easy stuff. Sodium. If sodium is by itself, is it a cation or an anion? If it's just sodium by itself, let's say you went and buy a block of pure sodium. Is it a cation or an anion? What's your answer to that? Right? Right, so this is actually a trick question, right? Remember, sodium by itself, when something is by itself, and it's not combined with anything, it is neutral. So it has a charge of 0. So this is not a cation, nor it is an anion. So it was a trick question. The same thing goes with magnesium. Magnesium, if it's by himself and it's not combined with anything, it's neutral. So that again is not a cation or an ion. Of course, I'm not going to try to trick you 3 times, but chlorine by itself, not combined to anything, is not a cation or an anion. You see, cations and anions only happens when it's, well, in most cases, I won't say always, in most cases, when it tries to combine with something. So if I have sodium chloride, okay, obviously for sodium to bond with chlorine, remember, it would have given chlorine an electron, and chlorine would have accepted an electron. So sodium would have a positive charge, and chlorine right now would have a negative charge, right? But when things are combined, we don't actually write the positive and the negative, right? And of course, if we dissolve sodium chloride, we will surely be able to separate the sodium positive completely from the chlorine negative, right? So in a case like this, the sodium is a cation and the chlorine is an anion. And of course, with magnesium oxide, because the magnesium is connected to the oxygen, the magnesium actually has a charge of +2 because it actually gives 2 electrons to the oxygen in an to form an ionic bond. So over here, we still have what? A cation and an anion. Today, the first thing we're going to be doing is testing for cations. Now, it's very important. We are not testing for neutral sodium, and we are not testing for neutral magnesium. We're not testing for neutral stuff. We are only testing for things that have a positive charge. Right. Now, if I am telling you that, let's say, next week you come to a class, and I tell you I have a cation, sodium positive. Do you know what the sodium was connected to? Like in this one here, I'm physically showing you that we have sodium chloride, so we know the sodium is positive and the chlorine is negative, right? But if I come and tell you I am testing for sodium positive a week from now, do you automatically assume it's connected to chlorine? What do you all think? If I come and tell you I have sodium positive, does that automatically mean it's connected to chlorine? The answer is no, obviously, right? For all you know, this sodium was connected to fluorine because it has sodium fluoride too, right? Well, obviously, the most popular one is what? Sodium chloride. It could have been sodium bromide, right? So whenever you are testing for a cation, you are just testing for the cation. You never, ever make an assumption of what it was connected to that made it into a cation. What it is connected to is 100% irrelevant, right? I want to make that perfectly clear, right? So you don't have to take down anything here, right? This is basic Form 2 stuff, so let's move on. So we understand the basics. And here, I'm not going to make you take down this table, but this table is going to be very important today. This was a table given last term, and I think I introduced this term as well. This table gives you a list of all the salts which are soluble and which ones are not soluble. It also gives you a list of all the bases which are soluble and which are not soluble. Also, it's very important for today that you remember, usually whenever you have an oxide or a hydroxide, it's most likely going to be a base. In other words, its pH is going to be more than 7. For example, calcium oxide. Once you hear the word oxide, most likely it is a base. And of course, if you have calcium hydroxide, once you hear hydroxide, you know it's definitely going to be a base also, right? But I had mentioned that last term already, but no harm in refreshing. So whoever wants to take a screenshot of this, you can, but I'm not going to give you time to draw back the entire table. So for those who want to take a screenshot, feel free to do so now. You have 10 seconds, and then we're moving on. Right, so don't get too scared, but don't get too comfortable either, because it's a little problematic. All right. So sometimes, just sometimes, you can look at a solution and look at its color. And based on its color, you could kind of come to a conclusion of what cation is present. So if you look at a solution of something and it's kind of blue or blue-green, most of the times it's be blue, right? You could safely assume in that solution or in that compound, it doesn't always have to be dissolved, right? In that compound, it have copper 2+. And I think a lot of people know this already. And one of the most popular substances in the lab is copper sulfate from school. And copper sulfate is blue. And there's a reason for that. Cu2+ gives out a bluish color, right? So also, if you look at something and it has a pale green color, not deep green, pale green, most likely it's iron 2+. Now, we have two versions of iron 2+ or iron 3+. If you look at something, and just by looking at it, whether it's a solution or whether it's a solid, right? If it's brown, yellow brownish, most of the times some people call it a dirty brown. It's Fe 3+. And ammonium, which is NH4+, I discussed this last week. Ammonium is a cation because it has a positive charge. Remember, ammonium and ammonia are different. Ammonium has no color, right? But however, it still smells like ammonia, that pungent, burning smell. It's very important to know, if you go in 3 different chemistry textbooks, they will describe the colors slightly different. So some textbooks might only have blue. They might not mention the blue-green. For the iron, instead of saying yellow-brown, some textbooks will say brownish, and some of them will say dirty brown. Remember, color depends on the person looking at it. You can look at something and say it's blue. Another person can look at it and say, hey, that's deep blue. Get accustomed with it, right? Different textbooks have different things. Take down this table, and once again, this is just how to figure out what cation is present by just looking at it, by appearance. Let me know when you are finished. All right, so let's see what's next. All right, so little cutscene here. So remember the humans who were working underneath Fufu Island, well, the slaves, right? They were planning an escape. And of course, the aliens planned to torture Jimmy here to get the plan. But as you may have noticed, this does not look like a torture room, but is it? So you can give it a read here and tell me if you all can relate to any of this. Give it a read, give it a read. All right. So the flame test now. Now there's a way to figure out what type of cation we have, but we need a flame. A flame and something else. We need a flame and concentrated sulfuric acid. So here's what to do. The unknown cation, you dip it on a piece of right? You dip it, well, the instructions are here. I don't know why I'm reading it back, right? So you take a small amount of the solid, whatever we're testing for, and you dip it in what? Sulfuric acid. And then you use platinum wire. You have to remember this for the exam. You have to use platinum wire. If you're wondering why we use platinum wire, platinum is very, very unreactive. The thing about it, you don't want the platinum taking part in the reaction. The only thing you want taking part in the reaction is the sulfuric acid and the thing being tested. And when you heat it over a flame, right? These are the colors you see. And I kind of made the colors look exactly like how they're supposed to look in real life. If it's potassium, like positive potassium, you'll get a kind of lilac color. Sodium is an orange yellow color. The flame will look that color. Calcium is brick red. Lead is bluish over the flame. And then copper is what? Blue green. So you're clearly seeing this is a memory game here, right? So take down this table, and of course, you have to find time to revise, to remember this. Right. So this is where the headache kind of starts here. So let me see if I can take my time and explain this. There's a test where you can take the unknown cation, right? And then you're going to add sodium hydroxide to it. Well, a solution of sodium hydroxide. So this is NaOH. And of course, if you're writing an equation, it would have what? An AQ. So tell me something. Sodium hydroxide, is that acidic or basic? What do you all think? Sodium hydroxide. What kind of solution is that? Is it acidic or basic? Right, we mentioned this just now, right? Sodium hydroxide is basic in nature. Therefore, it has a pH of more than 7. But it's supposed to. Right. So it's two things we're going to do. A lot of people don't understand this. So you have a test tube, right? You put the unknown cation inside here, so this little dot here, and we're going to put in very slowly some sodium hydroxide, not too much, just enough to react with the unknown cation. That's the dropwise, when we just add a little bit. So we add a little bit, we see what is happening, and after we note what happens, we add plenty sodium hydroxide after. So it's 2 steps. We add in the sodium hydroxide drop by drop, just note what happens, and after that, we throw in a whole set and then see what happens again. And that's what excess means. So if you throw a little bit of sodium hydroxide and you get a white precipitate, now the only reason you're getting a white precipitate, and then when you add plenty sodium hydroxide, the white precipitate remains, because the white precipitate is what? Insoluble. If that happens, it's calcium 2+. That's the cation. If you add a little bit of sodium hydroxide and you get a blue precipitate, and then afterwards you throw in plenty sodium hydroxide, and the precipitate is unable to dissolve, like you remain with the blue precipitate, it's copper 2+. And I think you getting the hang here of it, right? Iron 2+, you get a dirty green precipitate. And for iron 2+ and for iron 3+, when you add plenty sodium hydroxide, whatever precipitates you got are insoluble. For ammonia, right? For ammonia, sorry. This is supposed to be ammonium. Oh, look at it. For ammonium, when you add the sodium hydroxide, you get no precipitate. So if you get no precipitate, you suspect it's what? Ammonium. But when you heat it, you will get ammonia gas coming out of the solution, right? So ammonium does not produce a precipitate. But when you heat it, you will begin to smell the ammonia, that pungent smell. You notice so far, with the exception of ammonia, all the precipitates are insoluble. However, if you throw in sodium hydroxide and you get a white precipitate, and then you put in plenty sodium hydroxide, the precipitate disappears. You know why? Because this white precipitate is actually soluble. So it will dissolve in the excess sodium hydroxide. And of course, it will form a colorless solution. Now, if that happens, it could either be aluminum, lead, or zinc cations, but you cannot say which one for sure. All you know is that if this happens, it could be one of the three. The rest of them, like for the first one, if you do the test, you could say for sure it's calcium positive too. That cannot be contested. But the purple one gives you three things that are possible. So which raises the question, if you do the last test and you get these results, how do you eventually tell whether it's aluminum, lead, or zinc? There must be another test, a more complete test, a more expensive test, in other words, that could differentiate between the three. And of course, that will come up later. And it's the most asked question in qualitative analysis. Take down this table, learn it off by heart. All right, let's see. All right, so this is where so apparently in the tunnels underneath the ground, this is where the cutimals dump their trash in the cave. That's where the humans spoil utopia. However, they have come up with a plan to escape. If they could just simply use the things they find in the trash to build this escape machine here. So do me a favor, guys, just for fun in today's class. Take down these 8 items. And if you're able to get the 8 items today, we can build the airship and escape. Right? So make a note, just for fun, get a piece of paper. Right? Right. Let me know when you're ready to move on. All right, guys. So you get to choose 3 trash cans, and let's see what you find. Choose any 3 that you wish, and I'm playing the game too. So I will choose H, J, and Q. Right. So you choose your 3, and hopefully you'll get some of the items needed to what? Build the airship. Whenever you get an item, cross it off your list. And of course, as we play the game, your list is supposed to get smaller and smaller and smaller. So I'm H, J, and Q. Right. Let's see if you guys get lucky here. I got a piece. Well, the bottles are useless, right? The bottles, there are a lot of bottles in the trash can, and later on, you're going to realize why the aliens have all of these bottles in the trash cans. Anybody was able to get anything? I got a piece of wood, so I was able to scratch off one thing off my list. Somebody got the glue, somebody got a hammer, somebody got 2, a wood and a piece of hammer. Sarah, you got rope. All right, somebody got the screws, wood, somebody got wood and glue. You're lucky. Sorry, Sadia, next time. Let's move on. All right, so how about this? Why do, in the table I just gave you, if you look at it, why are so many precipitates soluble, and why are some of the precipitates not soluble? you're going to realize that in the table that I just gave you, the ones that had the soluble precipitate was the amphoteric substances, the A pink zebra substances. And it's no coincidence. So let's look at that test in more detail. Remember, let's say you have calcium chloride. So we testing for what? Calcium 2 plus, right? Because for calcium to be bonded to chlorine, it has to be calcium 2 plus. Just based on the table, what color precipitate do we get for calcium 2 plus? I just using this as an excuse to make you go back to the table and use it. What color precipitate? It's again, two different answers. Some people say brick red, and some people are saying white. They can't now. Somebody's wrong here. Check it back. I think the person who said white has it wrong. Something is wrong here, guys. Calcium. No. No, sorry. All right. Let's pause this here. Let's go on. Right. So calcium chloride, when you add the sodium hydroxide, right? We're talking about drops. We're just adding drops of it. This here is the reaction. You will most likely get calcium hydroxide. But calcium hydroxide is a base. It's basic in nature. It has a pH of what? More than 7. And it's this calcium hydroxide. This actually has a white color, right? It's a white precipitate. So what's going to happen now when we add extra sodium hydroxide? So the calcium hydroxide has just formed. So now we're going to add more sodium hydroxide. Sodium hydroxide is also a base. Will calcium hydroxide, which just formed, will it react with more sodium hydroxide? What do you guys think? What do you all think? Will calcium hydroxide react with sodium hydroxide? The answer is no, because remember I gave you a table just now. 2 bases will give you what? No reaction. So because the calcium hydroxide, which is the white precipitate that now formed, is not going to react with any more excess sodium hydroxide. So that means the white precipitate will stay. It's going nowhere. So that is why you get an insoluble white precipitate, because you're trying to what? React 2 bases together which have no reaction. However, right, if instead of calcium, you had used what? Aluminum. Let me get this out today. If instead of calcium, we had used aluminum. So let me scratch this off. We had used aluminum here. And instead of calcium hydroxide, we would have gotten aluminum hydroxide. Now remember, aluminum hydroxide is amphoteric. Anything with aluminum, lead, or zinc is amphoteric. So aluminum hydroxide is amphoteric. And of course, being amphoteric, he has no problems reacting with the base, because amphoteric things react with base or acids. So when the aluminum hydroxide, which is a white precipitate, reacts with the extra sodium hydroxide, now a reaction takes place and the white precipitate is no longer there. So that is why it will disappear. The white precipitate will not stay. And this is the note explaining it over here, right? Anything else here? Oh, you have to remember, well, this here are the general reactions, right? In case you're not understanding this, the Xn plus is really what? The calcium or what? The aluminum. And it mixes with the OH to give you whether it's calcium hydroxide or aluminum hydroxide. This is like the summary equation. And you also have to memorize the equation for ammonium chloride with sodium hydroxide. Memorize both equations, the full equations, and then you have what over here? The ionic equations. Okay? Take down everything on the screen. Let me know when you are finished. And the reasons I have both these equations here as examples, right? And the ionic equations is because I got them straight out of past papers. Right? So, all right. So there's another test for cations coming up, right? This was the sodium hydroxide test. Once again, this is when we add a little bit of sodium hydroxide. We observe what happens, and then we add plenty more after. Let's go. All right, so we're going through the trash again. Choose 3 letters, any 3 letters. Let's see if I get lucky here. I'm feeling lucky with Q, K, and X are going down here. Q, K, and X. Let's see if we can get all the parts for this airship to help us escape. Well, help them escape. Somebody said RDV. All right, let's see if you guys got lucky there. I got the glue. I got 2 bottles and a glue. I hope you guys had more luck than me. Somebody said they got the screws and balloons. Nothing again, Sadia. Somebody got screws there, Guardia, nothing. Somebody got lucky. They got a gas canister, a hammer, and balloons. 3 things. Well, some people have all the luck. All right, so let's move on. All right, so this one here is a different test for cations. This time we're going to use something called ammonia hydroxide. And this here is it. This is ammonia hydroxide. This is the chemical formula. I don't want to read through everything. Again, I think it's pretty easy to understand, except for the pink part. But let me just do one white part here. The calcium 2+, right? When you add, you're doing it the same way. I made a slight mistake here. This is supposed to be what? 1 second here. This is supposed to be NH4OH. Right, so it's the same procedure. You take this substance, the unknown substance, you're going to add a little bit of what? Ammonia hydroxide. You note what happens, and then you add plenty, and then you note what happens again. If it's calcium 2+, you will get no precipitate at first. And when you add plenty, well, if you didn't get any precipitate at first, when you add plenty more, well, nothing else going to happen. For copper, you get a blue precipitate, but when you add excess, the precipitate is soluble, right? But turns into a deep blue solution. Now, this is really important, right? Remember, a precipitate is solid. It's like something solid suspended in a liquid. So when you add a little bit, you get a blue precipitate, which is solid. But when you add plenty, the blue precipitate disappears. The solid blue precipitate disappears. But then the entire solution turns deep blue with no precipitate in it. So it's just a blue color, but no solid precipitate in it. For iron 2 plus, well, you get a dirty green precipitate. And when you add plenty, the precipitate stays because it is insoluble. And same thing for Fe3 plus, except it's rusty brown. Now, look at a pink zebra scenario, the amphoteric substances. This time, when you use NH4OH, you get a white precipitate at first. But if it is zinc, the precipitate is soluble and it dissolves to form a colorless solution. However, if it's Al3 plus or lead, well, whether it's aluminum or lead, right? You get a white precipitate, but this time the precipitate is insoluble. This is when you use NH4. Now I want you all to focus on the pink part because the pink part is the part that's hard to understand. Out of these two, the zinc or the aluminum, which one has the same exact results as sodium hydroxide? Is it the zinc or the aluminum and the lead? Which one has the same exact results as sodium hydroxide? Let me know on the chat. Look at it properly, right? You need to see this for yourself. For those who wasn't too sure, right? The answer is zinc. Zinc, whether you do the NH4OH test or the sodium hydroxide test, we get the same results. So this is going to be super important because remember, a few minutes ago, I told you that at first, there's no way to tell the difference between zinc cations, aluminum cations, and lead cations. But we're seeing that different tests give slightly different results. And how we get slightly different results, if we do both tests, it could narrow down whether it's zinc, aluminum, or lead. And don't worry, I'm going to spend plenty of time on this. I have special slides on this to help you out here. All right, so take down everything here. Let me know when you are finished. All right, so here's what you're going to do now, guys. You're going to pretend we in the lab here. Now, I need to make sure everyone gets this before they leave here today, right? So participate on the chat, try to produce answers. So here we have two tests. We have a test tube here with some unknown substance inside here. We add sodium hydroxide to it, right? So we do the sodium hydroxide test, right? Here's what happens. We note the results. When we did the dropwise precipitate test, we got a white precipitate. But then when we add plenty sodium hydroxide, the precipitate was soluble and it dissolves to form a colorless solution. What could it be? What possible cations could it have inside here? Based on those results alone. Angelique, correct. Kishan, correct. Samir, no, Samir, that's not correct. But not complete, right? Shanicia, right? Fritz, check it back. Brito, correct. Right. Here's the thing. For these results, if you look back at the table, it could either be zinc aluminum or lead, right? So it could be zinc 2 plus, aluminum 2 plus, so it could be either one of these. If you look at your results, for those who got it wrong, you think if it's just a matter of looking back at the table, when you get these results, it could be any one of these three. Now, imagine this. Imagine somebody is paying you $1 million to figure out exactly what cation it have in this test tube. And you come back and tell them, well, it could either be zinc, aluminum, or lead. I'm not too sure. Give me $1 million now. Do you think that person is going to pay you? What do you guys think? Not probably not. No, you're not going to get any money, right? Them ask you to figure out exactly which one it is. That's like you have a murder and you have 3 suspects: aluminum, lead, zinc, aluminum, or lead. And your job is to solve the murder. And you come back and say, well, it probably have 3 people who do it. I'm not too sure which one it is. End of case. No, right? You're going to get fired, right? So you say, all right. So the person says, hey, what? I'm not giving you that $1 million until you can tell me exactly which out of the 3 it is. I don't want 3. I want you to narrow it down to 1. So you say, all right. Let me do another test. So you put back the same substance inside here, and you add the ammonium hydroxide. So you do the second test now. The second test says you get a white precipitate, and the precipitate is soluble and it dissolves to form a colorless solution. What does it have in that? Based on the ammonium hydroxide test. Right. So now the second test boils it down to 1, right? It boils it down to 1. Now, I know what you're probably saying. Why you just didn't do the second test first? But it doesn't work like that. There's a certain procedure you have to follow in the lab, and there's good reasons for it, right? So you're going to realize your teacher will start you off with the sodium hydroxide, right? And then after that, if you have inconclusive results, then you do the other tests. There's a good reason for it. There's a good reason, right? So will you get the $1 million now? Now that you have identified it or boiled it down to 1 possible candidate, will you get? Now you get your $1 million, all right? So the first test did not give you $1 million, but the second test was able to narrow it down to 1. Take down everything on the screen there, everything. This is going to be super important because now, afterwards, we're going to have a slightly different scenario, and you're going to see the problem we're going to run into. Somebody had a good idea of what to do with their $1 million. All right, so I think we have a little cut scene here just for some relaxation. All right, let's see what's going on here. So apparently the humans have not been slaving hard enough. All right, so they're gonna torture Jimmy here. The other one has already gone crazy. All right, so let's do another one here now. Now, this looks the same, but look at this carefully. We are going to add some sodium hydroxide again, right? We get a white precipitate just like last time, and the precipitate is soluble. Fine. The first test indicates that it could either be zinc, aluminum, or lead. It can be any one of those. But then we do the test again because we're not going to get our $1 million there. But this time, when we do the second test, we get a white precipitate, but this time the precipitate is insoluble with the ammonium hydroxide. What could it be according to the second test? The first test has 3 suspects. Right? Right. I think it's supposed to be aluminum 3 plus. I have a little brain freeze there. The lead is a positive too, right? Right. The second test indicates it could either be aluminum cation or a lead cation. Will you get your $1 million? The second test, the first test had 3 suspects. The second test narrowed it down to 2 suspects. You're not going to get $1 million because whoever hired you wants you to narrow it down to 1. So you say, all right, at least it only have 2 suspects this time. It's clearly either aluminum or lead. Take down everything here. Now, the slide that's going to come after this is going to show you how to determine whether it's aluminum only or lead only, right? So it's like I said, it's a murder case. You had 3 suspects first in the first test. Your second test narrow it down to 2 suspects. And now there will be a next test, a third test that will differentiate who's the real killer or murderer or whatever crime it is, right? Let me know when you are finished. Let's see what's on the next slide here. Right. So remember, we just narrowed it down to lead and aluminum. So what you're going to do now for this $1 million? Well, there's this substance called potassium iodide, Ki, right? Potassium iodide. Now, if you take this substance now and you add potassium iodide and you get a bright yellow precipitate, then the substance is finally what? Lead. You can finally say now it is lead. If you take the potassium iodide and you add it to the unknown substance at this point and you get no precipitate, then it's what? Aluminum. So now, depending on which result you get, you can say exactly who is the murderer, whether it's lead, that's when you get the yellow, and aluminum if you get no precipitate. But usually, you just start off with all 3 tests. You'll start off with the sodium hydroxide. That should narrow it down to 2. To 3. And then you do the ammonium hydroxide, and that will narrow it down to 2. And then you go to this last test to narrow it down to 1. That's the normal procedure in the lab, right? And usually when your teacher is doing this experiment in school in the lab, they will do it the same exact way. They will make you do all 3 tests, right? So draw this final